There are several reasons why installing surge protection at the meter socket is not universally agreed upon, compared to installing it at the main panel. Firstly, consider the cost factor. Installing surge protection at the meter socket can potentially be more expensive than installing it at the main panel. The reason for this increased cost is primarily due to the location of the meter socket, which is generally outside the house. This external location necessitates longer wire runs to connect the surge protection device, which subsequently translates to increased labor costs for the installation. Secondly, another important factor is convenience. It is often more convenient to install surge protection devices at the main electrical panel. The convenience stems from the typical location of the main panel, which is inside the house. This indoor location provides easier access for installation, maintenance, and any future inspections or repairs. The ease of access can be a significant advantage for homeowners and electricians alike. Thirdly, the perceived effectiveness of surge protection varies depending on the installation location. Some individuals believe that surge protection is more effective when installed at the main panel. Their rationale is that the main panel serves as the primary point of entry for all electrical power into the house. Consequently, it is deemed the optimal location to intercept and mitigate surges before they can propagate throughout the electrical system. Considering these factors, the decision of where to install surge protection, whether at the meter socket or the main panel, ultimately comes down to a personal choice. Each option presents its own set of pros and cons, and the most suitable choice depends on individual needs and circumstances. Factors to consider might include budget constraints, ease of access for maintenance, and personal beliefs about the most effective protection strategy. Now, regarding the concern about bringing surges and lightning strikes further into the structure than necessary, it is a valid point to consider. However, it is crucial to understand the limitations of surge protection. Surge protection devices are designed to protect against smaller surges caused by various factors such as power outages, brownouts, and equipment failures within the home. These surges, while not as catastrophic as direct lightning strikes, can still damage sensitive electronic equipment. It is important to note that surge protection is not designed to withstand direct lightning strikes. Lightning strikes are incredibly powerful events that can cause catastrophic damage to electrical equipment, and no surge protector can completely prevent this level of destruction. A direct lightning strike will likely overwhelm even the most robust surge protection system. Bonding the neutral at the meter socket is a recommended practice to enhance the safety of your electrical system. Bonding refers to the process of connecting the neutral wire to the ground wire, ensuring they are at the same electrical potential. This practice helps to minimize the risk of electrical shocks and fires. The purpose of bonding the neutral and ground is to provide a low impedance path for fault currents to flow back to the source, which in turn facilitates the rapid tripping of circuit breakers or fuses. This quick interruption of power helps to prevent dangerous voltage buildup on conductive surfaces, reducing the risk of electrical shock. In summary, when deciding on surge protection, weigh the cost, convenience, and perceived effectiveness of installing at the meter socket versus the main panel. Also, remember that surge protection offers limited protection against direct lightning strikes, and bonding the neutral at the meter socket is a good safety practice. Understanding these factors helps you make informed decisions about protecting your home's electrical system. Electrical systems operate based on a few fundamental principles. Understanding them aids in comprehending surge protection. Voltage is the electrical potential difference between 2 points in a circuit, analogous to water pressure in a pipe. It is measured in volts. Current is the flow of electrical charge, like the amount of water flowing through a pipe, measured in ohms. Resistance opposes the flow of current, similar to the narrowing of a pipe restricting water flow, measured in ohms. These three quantities are related by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Understanding this relationship is crucial for analyzing circuits and troubleshooting electrical problems. Electrical power is the rate at which electrical energy is transferred, usually measured in watts, where 1 watt equals 1 volt times 1 amp. Different appliances and devices consume different amounts of power depending on their voltage and current requirements. Electrical circuits provide a path for electrical current to flow from a power source to a load and back. There are two basic types of circuits, series and parallel. In a series circuit, components are connected end to end, so the same current flows through each component. If one component fails, the entire circuit is broken. In a parallel circuit, components are connected side by side, so the voltage across each component is the same. If one component fails, the other components continue to function. In residential electrical systems, wiring is typically done in parallel to ensure that individual devices can operate independently. Electrical safety is paramount in any electrical work. Always turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as gloves and eye protection. Never work on electrical circuits in wet or damp conditions. Follow all applicable electrical codes and regulations. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Grounding is an essential safety feature in electrical systems. The grounding system provides a low impedance path for fault currents to flow back to the source, helping to protect against electrical shock. The ground wire is typically connected to a metal rod driven into the earth, providing a connection to ground potential. Ground fault circuit interrupters, or GFCIs, are devices designed to protect against electrical shock by detecting ground faults. A ground fault occurs when current flows through an unintended path, such as through a person touching a live wire. GFCIs quickly interrupt the circuit when a ground fault is detected, preventing a potentially fatal shock. Surge protection devices, or SPDs, protect electrical equipment from voltage surges, which are temporary increases in voltage that can damage or destroy sensitive electronics. SPD work by diverting excess voltage to ground, preventing it from reaching the protected equipment. SPD are typically installed at the main electrical panel or at individual outlets to protect specific devices. Electrical codes and standards are sets of rules and regulations governing the design, installation, and maintenance of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, or NFPA, which publishes the National Electrical Code, or NEC, which is widely adopted in the United States. Adhering to electrical codes and standards is essential for ensuring the safety and reliability of electrical systems. Understanding electrical concepts and safety practices is essential for anyone working with electricity or living in a home with electrical systems. Taking the time to learn about these topics can help you to avoid electrical hazards and protect your home and family from electrical fires and shocks. Electrical distribution systems typically start at the utility company's power plant, where electricity is generated. From there, the electricity is transmitted over high-voltage transmission lines to substations. At substations, the voltage is stepped down to lower levels for distribution to local areas. Distribution lines carry electricity to homes and businesses where it enters the building through a service entrance. The service entrance typically consists of a meter, which measures the amount of electricity consumed, and a main electrical panel, which distributes electricity to different circuits within the building. Circuit breakers or fuses protect each circuit from overcurrents, which can cause fires. Overcurrents can occur due to short circuits, overloads, or ground faults. A short circuit is an unintended connection between two conductors, such as a hot wire and a neutral wire. An overload occurs when too much current is drawn on a circuit, such as when too many appliances are plugged into the same outlet. A ground fault occurs when current flows through an unintended path to ground, such as through a person touching a live wire. The electrical wiring comes in various sizes and types, depending on the application. The size of the wire determines its current carrying capacity, which is the maximum amount of current that the wire can safely carry without overheating. Wire sizes are typically expressed in American wire gauge, or AWK, with smaller numbers indicating larger wire sizes. Common types of wiring include non-metallic sheath cable, or NM cable, which is used for general-purpose wiring in homes, and conduit, which is used for protecting wires in exposed or hazardous locations. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes come in various shapes and sizes, depending on the application. Common types of electrical boxes include junction boxes, which are used to connect wires together, and outlet boxes, which are used to mount switches and receptacles. When working with electrical circuits, it is essential to use the proper tools and equipment. Common electrical tools include wire strippers, pliers, screwdrivers, and voltage testers. Wire strippers are used to remove insulation from wires without damaging the conductors. Pliers are used to grip and manipulate wires. Screwdrivers are used to tighten and loosen screws. Voltage testers are used to verify that a circuit is energized before working on it. Regular maintenance is essential for ensuring the safety and reliability of electrical systems. This includes inspecting wiring for damage, replacing worn or damaged components, and testing GFCIs to ensure they are functioning properly. It is also important to keep electrical panels and equipment clean and free of dust and debris. Understanding how electrical systems work is essential for anyone who owns or lives in a home or business. By learning about electrical concepts, safety practices, and maintenance procedures, you can help to protect yourself and your property from electrical hazards. Proper grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices to quickly trip and clear the faults. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, reducing the risk of shock. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding. These requirements are designed to minimize the risk of electrical shock and fire. The grounding electrode system typically consists of a grounding electrode conductor, which connects the electrical system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a connection to earth, allowing fault currents to flow back to the source. Bonding jumpers are used to connect metal parts of the electrical system together, ensuring that they are all at the same electrical potential. Bonding jumpers are typically used to bond metal conduits, metal enclosures, and metal equipment frames. Surge protection is an important part of a comprehensive electrical safety plan. Surge protection devices, or SPDs, protect electrical equipment from voltage surges, which can damage or destroy sensitive electronics. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD work by diverting excess voltage to ground, preventing it from reaching the protected equipment. SPD are typically installed at the main electrical panel or at individual outlets to protect specific devices. When selecting an SPD, it is important to consider the surge current rating, which is the maximum amount of current that the SPD can safely divert. It is also important to consider the voltage protection rating, which is the maximum voltage that the SPD will allow to pass through to the protected equipment. SPD should be installed by a qualified electrician. Regular testing of SPD is recommended to ensure that they are functioning properly. Electrical inspections are an important part of maintaining a safe and reliable electrical system. Electrical inspections are typically performed by qualified electrical inspectors who are trained to identify electrical hazards and code violations. Electrical inspections can help to prevent electrical fires, shocks, and other electrical accidents. During an electrical inspection, the inspector will typically examine the electrical panel, wiring, outlets, switches, and other electrical components. The inspector will also test GFCIs and arc fault circuit interrupters, or FCIs, to ensure that they are functioning properly. If the inspector finds any electrical hazards or code violations, they will issue a report outlining the necessary repairs or corrections. It is important to address any electrical hazards or code violations promptly to ensure the safety of your home or business. Arc fault circuit interrupters, or FCIs, are devices designed to protect against electrical fires caused by arc faults. An arc fault is an unintended electrical discharge between two conductors, which can generate high heat and ignite nearby materials. FCIs quickly interrupt the circuit when an arc fault is detected, preventing a potentially fatal fire. Assays are typically installed in bedrooms, living rooms, and other areas where arc faults are more likely to occur. Assays are required by the NEC in many new construction and renovation projects. Regular testing of assays is recommended to ensure that they are functioning properly. Understanding the principles of electricity and electrical safety practices is essential for anyone who works with or lives around electrical systems. By taking the time to learn about these topics, you can help to protect yourself and your property from electrical hazards. Always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. Electricity is a powerful force that should be treated with respect.